Hello. Today we're going to talk about energy, electrical energy stored in capacitor, in a capacitor. Okay. So this energy is an internal energy. So we're going to say that's a U. Okay. And if you like to put a C there, it's fine. So parallel plates. Okay. So you connect it, right? So it's uncharged right now. So uncharged, right? So then this is plus, this is minus, right? So this is metal. So inside there, if you just looking into it, inside there, this is inside, right? And there are atoms, and they are, they are nucleus. In the atom, there's a, E minus in the outer shell, right? So in the outermost shell, so the E will be attracted. So the E will start coming down, right? And then this side will start populate this one here, minus and plus. You just say that's one electron, and that's losing one electron. Okay. So right now, right? So you are this V here, the V that's inside the C, obviously, it's not the same as the V there, right? So you have this current going, right? You have electron current going this way. All the currents going that way, right? Electron current going that way. So because there's a driving battery right there. So you see, you are overcome. So you have this small q right now, right? You have a small q, you have a small VC right now. So look at this. Now you kind of like a charging the parallel plates, right? So let's say if I want to put my q there, or you want to put v there, it's fine. V there, right? So basically, this charge is being stored in there with a little v and a little q, right? So it'll be like right there. All right, so now you have a second electron goes there, and now you have this now. So now you're somewhere there, okay? So you're charging it. So as you charge, this is going to go like that. So it's a triangle, you see that? And that's the energy that you store in there, okay? So the energy is equal to the area of triangle, okay? And if you want to call this one here Q, okay, kind of abusing the terminology, and call that one V. So this one here is equal to 1/2 QV, right? High and base. QV right there, okay? Okay, so that's the energy, electric energy stored in there. And now you can say Q is equal to CV to get the other form, right? So you can put that in there, you can manipulate, you'll get a different form. And this is, of course, is in joule, right? Units. Okay, so now let me ask you a question, right? So let me ask you a question. I'm going to clear that. So at this point, I say, well, I got a parallel plates, and it's all charged right now, right? So fully charged. So now this is the V that was the battery, right? The battery now disconnected, and now I got V there, and I have the Q there, okay? Now, if all of a sudden I'm putting something with a non, it's not a 1 kappa, right? So kappa, right? So kappa, right? Kappa, a Greek letter. Kappa looked like a K. So the kappa, let's say for mica, right? Put a mica there, the material called mica, right? So, and this is a dielectric that I put in. So what would happen to the store energy? Okay, so what will happen to the U now with the mica in there? Okay, so it was this here. There's no kappa, right? So I have my Q, I have my V, right? So the energy U will be equal to 1/2 VQ or QV. And now if I put my kappa in there, right? So I know the C will be different now. It's not epsilon 0, it's epsilon, right? And D didn't change, okay? D didn't change. A didn't change. area didn't change of one of the plate. So A, D. But epsilon change, right? This is equal to K epsilon 0. So this is epsilon here, free space. But this is not, right? This is now dielectric, so this is epsilon. So I know my C now has increased, right? So C has increased now, right? Compared to the epsilon 0, C increased. Okay, so Q equal to CV, right? Q doesn't change, right? You put that in there, Q has no place to go. It's not connected to battery. So in this case, Q doesn't change, so this stays the same. But this one increase, so this one must decrease. That means the voltage difference between, oh, sorry, minus, between these two plates has decreased, okay? So you can see the U now is equal to 1/2 QV. Once you put in this dielectric, the U, right, for the mica, right, actually reduce because Q is the same and V goes down. All right, even though C increase. Okay, that's all we have for today. Okay, bye-bye.